Welcome to another session of Grade 9 Mathematics, Chapter 7, Triangles. Dear students, in this fifth and the last part of the chapter, we shall be discussing in detail the solutions to NCERT exercise 7.4. Let's quickly get to the first question of exercise 7.4. Question number 1. Question number 1 of exercise 7.4 states that show that in a right angle triangle, the hypotenuse is the longest side. What are we supposed to prove? That in a right angle triangle, the hypotenuse is the longest side. Now, many of you must have already realized it, that the hypotenuse is the longest for a right angle triangle while doing sums related to right angles. But then let us give a written explanation for the same. Now, let us consider triangle ABC such that angle B is equal to 90 degrees. Consider the figure that is there on your screen, triangle ABC, wherein angle B is equal to 90 degrees. Now, I know that the angle sum property says that the sum of all the angles of a triangle has to be equal to 180 degrees. That means angle A plus angle B plus angle C should be 180 degrees. But then I already know what is angle B, that is 90 degree. So angle A plus 90 degree plus angle C is equal to 180 degree. Now if I try to find what is angle A plus angle C, that would be 180 minus 90. So what is 180 minus 90? It's 90. So angle A plus angle C is equal to 90 degree. But then can I write that angle A plus angle C is equal to angle B? Yes, because 90 degree and angle B are equal to one another. So what is the conclusion as of now? That angle A plus angle C makes up angle B is equal to angle B. This also gives a conclusion that individually angle A and angle C are less than angle B. Or in other words, angle B is greater than angle A and angle B is also greater than angle C. Now, if I consider the side opposite to these angles, I can easily conclude that AC is greater than BC. Similarly, AC is also greater than AB. How did I conclude this? Sides opposite to the given angles. Therefore, AC is greater than BC and AC is greater than AB. So which is the longest side? AC is the longest side. But what is AC in this right angle triangle? It is the hypotenuse. So now I'll conclude that yes, in this given right angle triangle, the hypotenuse is the longest side. I hope now you're all clear with the solution to question number 1. If yes, then let's quickly get to question number 2. Question number 2 says, in figure 7.48 of your textbook, sides AB and AC of triangle ABC are extended to points P and Q respectively. Also, angle PBC is less than angle QCB. And we have been asked to prove that AC is greater than AB. So what is given first? That AB is extended to point P, you can see in the figure, and AC is extended to point Q. The given other fact is that angle PBC is smaller than angle QCB. Okay, let's get to the solution. Now, if you consider the side AB, P, I can easily say that angle ABC plus angle PBC should be equal to 180 degree. What's the reason? Because they form linear pair of angles. Similarly, if I consider the side ACQ, I can say that angle ACB plus angle QCB should be equal to 180 degree because even they too form linear pair of angles, isn't it? Now, what is given? Given that angle PBC is less than angle QCB. Yes, and they're equal to 180 minus angle PBC will be then greater than 180 minus angle QCB. So, what is 180 minus angle PBC? Yes, it is angle ABC. Yes, what is 180 minus angle QCB? Yes, it is angle ACB. So, what did we conclude right now? That angle ABC is greater than angle ACB. Now, considering the side opposite to them, yes, the side opposite to angle ABC will be greater than the side opposite to angle ACB. Now, if we look into the figure and find which are those sides, we can easily conclude that AC is greater than AB. This was solution to question number 2. Now, let's get to question number 3. Exercise 7.4, question number 3, which says, in figure, angle B is less than angle A. So you look into the figure as well. Angle B is less than angle A and angle C is less than angle D. Show that AD is less than BC. So what are you supposed to show? That AD is less than BC. Let's quickly do that. This is going to be an easy one. Now, since it is given that angle A is greater than angle B, I can easily say that the side opposite to them would also be greater. Therefore, OB is greater than OA. Similarly, considering angle C and D with the given fact, I can easily conclude that OC will be greater than OD. Yes. So what have we got? OB is greater than OA and OC is greater than OD. Now, if I add this first and the second equation, what would I get? The LHS get added together and the RHS get added together. So OB plus OC is greater than OA plus OD, isn't it? Now, what is from the make it up from the figure? What is OB plus OC? Yes, it is BC, which is greater than what is OA plus OD? Yes, it is AD. So, what did we conclude? That BC is greater than AD. Yes, I hope the solution was pretty easy to be understood. Yes, let's now get to question number 4. Exercise 7.4, question number 4. It says, AB and CD are respectively the smallest and longest sides of a quadrilateral ABCD. So, which is the smallest side given? AB. Which is the longest side given? CD. What are we supposed to prove? Show that angle A is greater than angle C. Angle A is greater than angle C and angle B is greater than angle D. And you could see the figure given over here also. Let's quickly get to the solution. What I've done is first join A to C. Now in triangle ABC, if you could observe, AB is smaller than BC because it is already mentioned that AB is the smallest of all the sides. So I can conclude that AB is smaller than BC, or in other words, BC is greater than AB. Now, if I take the angles opposite to them, I can conclude that angle BAC is greater than angle BCA. Similarly, in other triangle, that is triangle ACD, yes, it is given that CD is the longest of all in ABCD quadrilateral. So in triangle ACD, I can say that CD will be greater than AD. So the angle opposite to them, that is angle CAD, will be greater than angle ACD. Yes, so I've got two equations, equation 1 and equation 2. Equation 1 is angle BAC greater than angle BCA. Equation 2 is angle CAD greater than angle ACD. Add these two equations. That is LHS get added with LHS and RHS get added with RHS. So what do we get? Angle BAC plus angle CAD will be greater than angle BCA plus angle ACD. So if we could see what is angle BAC plus angle CAD, yes, it together forms the whole angle A. Similarly, what is angle BCA plus angle ACD? Yes, it together forms the whole angle C. So what have we proved? That angle A is greater than angle C. Similarly, you can prove the second part of the question by simply joining B to D. Try doing this on your own in a way very similar to what has been done here on the screens. Yes, I believe that will be an easier task for you guys to do it. If that's the case, let's proceed to the next question. Exercise 7.4, question number 5. It says that in figure, PR is greater than PQ. PR is greater than PQ. And PS, the side, PS bisects angle QPR. So angle QPR is getting bisected into two parts, okay, into two equal parts. What are we supposed to prove? That angle PSR, look at the figure, angle PSR is greater than angle PSQ. Shall we proceed with the solution? Yes, let's do that. Now, if you could see, it's already given that in triangle PQR, PS bisects angle QPR. So, can I conclude that angle QPS will be equal to angle RPS because they're two equal parts? Yes. If those are equal angles, yes, it is also given that PR is greater than PQ. PR is greater than PQ. So the angles opposite to these sides would also be equal. So opposite to PR, we have angle PQS, and opposite to PQ, we have angle PRS. Yes. Now what I'm going to do is I'm going to add angle QPS on LHS and angle RPS on RHS. Why could I add this? Because they're equals. And when equals are added to equals, the whole remain the same. That is what Euclid's axiom did convey us. So what I did right now is I have angle PQS plus angle QPS greater than angle PRS plus angle RPS. Now, if we consider angle PQS and angle QPS, they are the two interior angles, and that will be equal to the exterior angle PSR. So instead of writing PQS plus QPS angle, I shall write exterior angle PSR. Likewise, on the other side, instead of writing PRS plus RPS, I may write exterior angle PSQ. So hereby I can conclude that angle PSR is equal to angle PSQ. I hope you have understood the solution to this question number 5. If yes, let's proceed to question number 6. Exercise 7.4, question number 6. Show that of all the line segments drawn from a given point, not on it. So there is a point which is not on the line segment, which is outside the line segment. From that point, of all the line segments drawn, okay, towards that line, yes, the perpendicular line segment is the shortest. The perpendicular line segment is the shortest. Now let us consider a diagram as shown on the screen. We have a triangle PMN such that angle M is perpendicular. That is, angle M is equal to 90 degrees. Now, if you consider the angle sum property of triangle PMN, angle M plus angle N plus angle P should be 180. Now, here angle M is equal to 90. So, as we did in one of the previous question, replace M with 90 degree. So, what do we have? Angle N plus angle P is equal to 180 minus 90. That is, angle N plus angle P is equal to angle M, which is 90. Yes. So, what we can conclude that angle N is smaller than angle M. Yes. Similarly, angle P is also smaller than angle M. So, if angle N is smaller than angle M, PM will be smaller than PM. Similarly, PM will also be smaller than PN1, and PM will be also be smaller than PN2. So from these conclusions, we actually have PM as the smallest line segment drawn from P on the line L. So we can conclude that yes, the perpendicular line segment is the shortest line segment drawn on a line from a point which is not on it. I hope you're all clear with the solution to question number 6. With this, we come to the conclusion of exercise 7.4 as well as to the conclusion of NCERT solutions of chapter 7 triangles. I hope you have understood chapter 7 through this video explanations. Please practice well so that you can do well, perform well in your examinations. This is all for now. Take care of yourself until we meet next time with another session. Thank you.